In this one, we have two lessons or two chapters. First one is exception fundamentals and advanced exceptions. Okay. In this one, we will create our custom exceptions as well. All right. So first we will see try catch block finally and also difference between checked versus unchecked exceptions. Okay. Exception handling fundamentals. Exceptions are Java's mechanism for signaling, propagating, and recovering from runtime errors. Okay. When something unexpected happens, a division by zero or an access through a null reference, okay, sometimes a missing file, and maybe some network fail, our JVM creates an exception object and throws it up the call stack until some caller either catches it or the program terminates. Okay, and our goal of exception handling is not to silence errors, but to respond to them at the layer that actually knows what to do. Okay, translate them into user facing messages and retry the operation, roll back a transaction, or fail fast with context attached. So basically, we will handle our errors gracefully, okay, and we want our program keeps running, all right. So in this chapter, we will see what exception actually are and why they even exist, and exception hierarchy we will see, all right. And then we will see some differences between checked and unchecked exceptions, okay. Also, we can create our custom exceptions according to our use cases, right? So first, let's see what triggers an exception or what is an exception, okay. So let's say we are writing one calculator app and any line of code here, let's say user enters two numbers, we have to divide them, simple, okay. Look simple this one, but if our denominator is zero, then this one is not valid syntax for division, right? So here we have to do something, and we call that arithmetic exception, integer division by zero. So any line of code that violates a language or API contract can throw three common runtime violations: array index of bounds. So these are most common, null pointer and arithmetic, but we can have many more. Okay, we can also have some custom exceptions. Now, without a try catch, and what is that? We will see. Okay, any of these propagates. Okay, these one up the stack. Okay, we know how stack works and layers by layers, right? So if nothing catches that any kind of exception, then our program will terminate and terminates the thread with a stack trace. Okay, so we will also get trace like where that thing happened. So basically, if we say more about what exactly is an exception, so exception is basically one event, okay, that disrupts the normal flow of our program when something unexpected happens. All right. And when that unexpected happens, then our Java will create one exception object basically, okay? And that object will contains some information about what went wrong, okay? The type of error, some messages, okay? And also we will get the exact line where that happened. And then our Java will throw that exception object, okay. And also Java stops what it's doing and looks for someone to handle that problem in our stack, okay. So basically our Java will search for handler, and our Java propagates to chain of methods looking for code that knows how to deal these kind of exceptions, okay. Now we have two choices: either Java finds that handler, okay, who handles that, or Java will crash and our program will terminate at that point. But we don't want that, okay. Sometimes we want, if the error is critical, then we want our program to terminate, but sometimes we don't want like this. We don't want this one, okay, to like terminate our program. we can handle this case. All right. So let's see this one. We can clear this. Okay. Remove this for now. Our IDE will also show some warnings here. Numeric overflow in expression. Okay, but compile this one because we will not get this one in our compilation phase. We will get this one in our runtime phase. Okay, and you can see we have here our stack trace. This one is in thread main. Okay, all right. And let's see if we have another method that is public static or not. Okay, we have to make this static and divide here int a int b, and we can return this one, and from here we can call this one. Okay, so divide 10 0. Okay, now we will get some different stack trace. Run this one, you can see we have first main, then we have this one divide. Okay, and we got this one in line number 9 here. All right, now how can we deal with these kind of exceptions? Before that, let's see exceptions hierarchy. Okay, so everything that can be thrown extends this one, java.lang dot throwable. The two big subclasses have very different meaning. Okay, so we know that in Java, all exceptions and also errors are objects, and like objects, we have class hierarchy. Okay, so at the very top is a class, we have that throwable. Okay, and everything that can be thrown, or we can say reported as an error, extends from this one. Okay, first one is error versus exception. So basically we have two things here. First one is error and second one is exception. So error, we definitely not try to handle these kind of things. Okay, error, serious JVM problems, do not catch those. Something like out of memory error or stack overflow error. Okay, because in this case our JVM ran out of memory and there's nothing our code can do about this. And also in this case as well, too many method calls. Okay, so our program structure is broken. Maybe we can have some JVM errors. Okay, so we have one rule for this one, these kind of errors that don't catch them. And basically in these kind of states, our program is at one point where it can do anything. Okay, right. Our next category is exception, application level problems. So basically our exceptions represent problems that a well-written program might want to catch and recover from. Okay, so let's say that our file not found, right? So we can use some default instead, right? And user entered some invalid input. Okay, so we can ask them to input again. Arithmetic exception, we can handle this one. Okay, null pointer exception, we can also recover from this. And array index out of bound exception, we can also handle this one. Okay, now we have also split in this category as well. In exception, we have here two categories, runtime exception, and that is unchecked, and everything else that is checked. Okay, so in runtime exception, the compiler doesn't force us to handle them, right? Like in this case, arithmetic exception, this one happened. Our compiler isn't forcing us to handle these kind of exceptions because we are compiling. Okay, and our second category is checked exceptions. And in this case, we must handle those exceptions. Okay, if there is any probability that we can get these kind of things, then we must handle these exceptions. Okay, and our compiler requires us to handle them. Okay, Error subclasses represents problem the JVM cannot reasonably recover from. Okay, we definitely don't want to catch them. And exception subclasses represent conditions the program might want to handle. Okay, now checked versus unchecked exceptions. We have seen this one. So further, this one checked exceptions, subclasses of exception, but not runtime. The compiler requires every method that um, might throw one to either catch it or declare it with throws. Okay, we will see. These are used for anticipated external failures. Then unchecked exceptions. All right, checked, unchecked, compiler enforced. Yes. Common examples: IO exception, SQL exception. Okay. And then we have unchecked, NDE. Okay. Arithmetic, illegal argument exception. All right. So basically, our philosophy for unchecked is that we did something wrong in our code. Okay, so we can handle those things, right? But for checked, we call them some external problems. Okay, so things can go wrong that are not our fault, and further we can prevent through by doing some better coding. All right. For example, you can say in this one, our user asked to open one file that doesn't exist. Okay, so we can prevent users from typing wrong file names, right? Same goes for here. Okay, so overall philosophy for these is that these are not our fault, but we must have a plan for them. Okay, now next one, try catch block. Wrap risky code in try. Okay, specify how to respond in catch. On an exception, execution jumps immediately to the matching catch block. Everything between the throw point and the catch is skipped. Okay. So in this case, like here we did, we can wrap this one in our try catch block. Okay. So try, return this one, and if exception occur, then we can catch that one. And here we know that arithmetic exception can occur here. Okay, so we can be more specific here. Then we can return 0, but we can also throw something. Okay, so here we can print error, but we can also call something e dot get message. Okay, so we can use that. Now this one E is the exception object with details about what went wrong. Okay, we can know about them. Okay, so let's understand here flow. So Java enters this try catch block. Okay, and starts executing code line by line. First statement is that if no exception occurs, okay, then the entire try block executes, and this one will be skipped. Okay, but if exception occurs in this statement or in any line, then execution will immediately jumps to the catch block. Okay, and remaining lines in try are skipped. And after catch completes, execution continues normally after the try catch. Okay, after this block. Okay. Now we can also have multiple catch blocks. Okay, so different exceptions often need different responses. So let's say we have some another here. Okay, so or maybe we can skip this one. Maybe we can write here something. Okay, so try, and okay, we can call that, but here we can catch something. Okay, so let's say first one is file not found exception, and then here we can also catch something IO exception. Okay, then we can also catch another one that is the topmost in hierarchy. Okay, in exception E, if we don't know like what can happen. Okay, so we can go like that. We can print this, and here is never thrown in the corresponding try block. Okay, so here we are getting this one is never thrown in the corresponding try block. Okay, so we can create here something, right? That is, we can try to read something, file reader, and this one, okay, now we are good. All right, and this one will start where that file is here. If this file is not present in src, then we will get one error. Okay, what is here? Catch branch identical to branch. Okay, no problem. So just for understanding, we can comment out this one for now. Okay, and we can try to call this one now. We are calling. Okay, so we are printing here, and here let's print successfully handled. Okay, our exception. Okay, all right. And previously we have seen that we were getting our program terminated. Okay, but let's see this time. Compile and run this one. So our program continues running. Okay, even we got this exception here, error by 0. Okay, all right. In this case, our order matters. Okay, so Java checks catch blocks from top to bottom and uses the first one that matches. Okay, and since parent exceptions match their children, like this one, okay, because anything that can be covered inside this, absolutely we can cover inside this. Okay, because if you go inside that, then you can see this one extends IO exception. Okay, and this one extends exception. Okay, so if you put this one on top here, then you can see here that we are getting one error. Remove this one for now. We are getting error here that exception this one has already been caught, because this one will cover this one, because exception is basically parent to this one. Okay, IO exception. So we can cover everything from parent. Okay, so you must put this one as your last choice. And if you put this one first, then it catches everything. Okay, and the more specific catches below, like this one, become unreachable, and we will get one compilation in this case. Let's see. If you try to do that, this one, IO exception has already been caught. Okay, all right, then we can have one different syntax. Okay, so sometimes we want some multiple exceptions to be handled in the same way, okay, rather than different catch blocks. So how we can do that? We can write here IO exception, IO exception, IO. Okay, we can do that. So IO exception, and we can put here pipe operator. Okay, now you can see multi-catch must be disjoint is a subclass of this one. So we cannot do that here. What we can do, we can put here something SQL exception. Okay, now what is that? Is never thrown in the corresponding try block. Same thing, we will not get this exception in this case. Okay, but this one is just for understanding. So this one basically means or. Okay, and we will start looking from here. I hope you got the point. Okay, we will start looking from here. Okay, so we can clear this one. Our next thing is, sometimes we want that some part of our code definitely runs whether we are getting exception or not. Okay, and for that we have one finally block. Finally guarantees that our code will run finally, and here we can do something finally. Okay, if no exception occurs, then still our finally will run, and if exception occurs and is caught, then still after this catch block we will get this one. Okay, and if exception occurs and still not caught, then still we will get this line. Okay, even if we have some return statement, okay, let's say here, even if we have some return statement here, then still our finally runs before returning. Okay. So now the question is, can we stop this code? Yes, we have one way. We can use system.exit. Okay. So let's see here. Why not just remove this thing? We can handle here. Okay. And for now, I guess, or maybe that's fine because we will get one here and we can do this one. Okay. We can remove this for now. All right. Here we can print dot out dot println and error. Okay. And here we can print e dot get message. Now what is that? Used without try with resources statement. Okay. That's fine for now. We will see what is try with resources syntax in our later part of our series. But now compile this and run this one. No such file or directory. Okay, so we handled that. We got that error here. Okay, so still we are doing this return statement, but we are getting our finally block. But if we write here something in catch statement that we are getting system dot exit, we can provide here some code, let's say 0. Okay, if you compile this one and run this one, now you can see we are not getting our finally block code. Okay, so that's how we can stop this code, this block as well. But usually we don't do that. Okay. Okay, now let's fix this one as well. So you can see here, file reader used this one, try with resources statement. So we can use this syntax, not here. Okay. So remove that for now. And we can put here file reader and reader equals to, we are not getting any suggestions, file reader. Okay, then we can put here anything, file dot text. Okay, now what's the problem here? Unhandled exception from auto closable resource, IO exception. Okay, and we can handle that here, IO exception. Okay, and here we can print finally. Okay, that's fine. Here we can do something error.get message. All right. So basically any class like this one, file reader, that implements our auto closable can be used this way. And if you open this one, we will cover that thing later. So this extends our input stream reader. If you go inside that, extends reader, and if you go inside that, closable. Okay, implements readable, closable. And if you hover on that, you can see closable extends auto closable. Okay, and if you go inside that, then you can see this one. So we have this interface in the hierarchy of this file reader. Okay, so we can use this one like that. And we call that syntax try with resources because now we don't have to close this resource. Okay, and we will cover what happens if we don't close basically these resources because we have limited number of that handles. Okay, and if you keep just opening your resources and you are not closing, then eventually you will run out of handles. Okay, and this one is the preferred approach. Basically what we can do now is multiple catch blocks, that's fine. Order matters. The finally block. Okay, try with the resources, common exception types. We have first one null pointer exception, then array index of bound, then arithmetic, okay, number format. This one is class cost exception, okay, illegal argument exception, file not found exception, and IO exception. Okay, we have quick summary here, and we can move forward with advanced exceptions. Okay,